Okay, Speaky, can we start? Great. Hello, party people, and welcome to the next panel. And this time the theme is social code. And what is this panel all about? It's about coders. We have here 3 esteemed C64 coders sharing you their tricks, and we will discuss some history of C64 coding. We will look into the future of it. They will also tell what sort of tools they use. So here's an opportunity, if you want to get into it, to hear it from those masters of the trade. I'm Marq Reuranen, and I'm not much of a C64 coder, actually pretty awful C64 coder. Most of my 8-bit coding I've done for the MSX computers, so I'm sort of in the enemy turf here, so to speak. But luckily we have here more seasoned coders. MSX rules. So, when you do those games, when you do that demo there, there's the 3 basic ingredients you need. You need that sound, you need that code, you need that music, maybe even a hint of design. And really, code is the engine that makes the car run. We could put it that way. So that's really one of the essential pieces, or things just won't work. And today the focus is on code. And from the right, I will present our panelists. First, we have Scorpion of Artline Designs. Then we have Tape from Extend. And the grand old man, our international guest, Trap from Bonzai.
I'm not old.
Grand old as in grand, not old. So, instead of me babbling here, let's hear it from our panelists. So, all of you, would you discuss your current projects? What are you currently doing? And what is your history with C64 coding? Would Scorpion maybe start from the right?
Yeah, hello. I'm Scorpion, and I started working on this machine in my teens in 1980 something. And it was the usual story, I think. So some friend had a C64 and I had to have it too because the games were nice and so on. But then after some time I heard about some guys that actually were making something themselves on the machine rather than just playing games. And then I knew a friend who knew a friend who could do something on the machine, and then I got some demos, and I saw those and thought that, oh my God, is this possible? But can I do this kind of stuff myself? Well, I couldn't, but then I started learning. And back in the day it was different from today, so there was no documentation, no information backs or code base or anything like that. So you looked at other people's code and took something there and tried to do it your own, take some pieces here and some pieces there and see that does this work if I do it like this and so on. And it started there.
Right. I bought my first computer when I was 8 years old. That was 1983. That was a shitty computer. It was called Basic 2000. It has 2 kilobytes of RAM and rubber keyboard. And all the things you could do with it was only programming, because nobody had those machines. There were no games for it. It came with the 10 basic listings that you could try out. And very soon I found out that the friends also had C64, so maybe a year or two later I had the C64 also. For demo coding, I started very early also. I didn't have great tools for that. I had just assembly monitor that I used for creating basic text scroller over image. That was my first kind of release thing. It was to a crack intro. And yeah, times have changed since. So I've been programming for 40 years now, and I still remember the first things I programmed with the computer. Nowadays things are much easier than at that time, and faster. And yeah. Nowadays, I haven't forgot, of course, my C64 coding. I do it regularly and just try to help with our demo group's projects whenever I can. And yeah, there's a lot of history in between that start and this date, and maybe we get to talk about it more in this panel still. So.
Okay, I'll make it super short. So I bought my C64 some time ago by pure accident. When I only had a tape deck, I didn't have a disk drive like you rich guys. So a lot of the old demos, actually the first Lethal Display demo was made using a tape deck. I sometimes borrowed a disk drive, and that's how I could actually finish the demo. But that's one of the reasons why it's 2 files. I didn't have time to make it load up parts and everything. Anyway, I got a C64, and I got these tapes from friends with legally copied entertainment software on them. And one of these programs was the Mercenary Cracker music collection something. And I was blown away that this is an ordinary guy who did something that's almost more cool than the games we're playing. I gotta figure out how this is done. So I asked the same friend, do you have something so I can do that? And he gave me a copy of S-Mon, if you guys remember that one. And that's how it all started. So some of the first code I did was made in S-Mon using a tape deck with a green monochrome screen. So that's the reason for the coder colors from me. from me. And well, today we re-entered the scene in 2014, doing the Phoenix code that was released in 2016. And we always have this thing that we create the effects. Walt gets an idea, Ricky gets an idea, I get an idea. We code the effect, and then we just put it on the shelf and just have it lying there. Eventually, we reach critical mass and say, okay, we got to make a demo out of this. Usually, it's me who has some stupid idea for a theme or something. If we don't have any code, I'll do even more stupid stuff like the pumpkins, if you remember that one, or the Santas, or the seniors, or whatever is going to happen eventually sometime in the future. So there's always something happening.
Thanks, guys. I too remember those cool crack intros from the 80s when I saw them on my friend's C64, and it was always like, what is this, what is this? Press space, let's go to the game. So it took a while to appreciate the art. So I wasn't as much impressed maybe as Trapp here. Yet
I never hit space, you know. I was just looking at the intros there.
Okay, many of you have experience from 20, 30, even more years of C64 coding. How has it changed over that time? Some observations. How is C64 coding these days different than what it used to be?
Almost nobody is doing C64 demos on a C64 anymore. That's one thing. I think I can safely speak for pretty much everybody that we're using some sort of emulator. And we are writing the demos on PCs in Windows or Linux or Mac, whatever. And so the whole development cycle has changed radically. Instead of, back in the day, we would sit on the machine and code with the assembler loaded in memory, using half of the memory and having no resources left. And if we accidentally turned off the machine, everything would be lost unless we remember to save it. Today, it's so easy. You just hit F5 and the entire demo is just running right in front of your eyes on the same machine. You have multiple instances. You can stop the machine. You can look into memory. A lot of the stuff you could do back in the day, but it's so much easier now, the whole turnaround.
And faster. At the end of the 90s, it was the last time I used only C64 for the demo coding. It's a while back already. And as an example, the demos, demo effects I did then, they needed some pre-calc because they were doing some full screen rotating thingy, and you had to pre-calc it all. I did it in C64 Basic. And one pre-calc could take 2 hours, and you hope that it doesn't crash in the way. And only after the 2 hours you will see if it did work. Then you tweak the parameters, wait for 2 hours and try again. And just a couple of years later, I did the same pre-calc in some Pentium processor, Pentium 100 or something, and Pascal. It took 3 seconds. And nowadays, it would take like microsecond or something to do the same thing with a high-level language. So it's gotten very much faster. You can iterate much faster. You can try things much faster. You can basically tweak these parameters real time and see what comes out. And that has really changed the game. So you don't have to pre-think everything. You can just try it out and see what comes out. And just take seconds. The tooling has changed a lot. Like I said, in the 80s, I did everything in machine language with a monitor. So if I had to add code somewhere, I had to manually move memory to make space for new code and change the commands in the between. Then at the 90s only, I found these assembler programs that you can actually write the text and compile it. That was already fine. But for the modern tooling, I always use the languages and tools that I use for my work. It has include Pascal, Visual Basic from Microsoft. Nowadays do everything in Python. And just gets easier for me because I'm using the same language at work and in hobbies. Yeah, tooling is everything nowadays.
Yeah, I certainly see it's the same for every one of us. So back in the day when you were coding with the real machine, then first of all, if you wanted to actually do something productive, then you would need to have an assembler or a cartridge with a machine code monitor like Action Replay. Then you could do something. The thing with assembler like Turbo Assembler is that if you don't have any extra memory or whatever and whatnot, then that assembler takes a portion of your memory. So certainly you cannot do a thing that demands kind of the full memory of the machine.
Well, if you remember, there were actually a few, like Walt, he had 2 C64s. So he had a C64 and there was client programs, so he would send the program over to the other C64.
Yeah, I remember those.
And there was a group like Upfront.
Yeah.
Upfront, they had this cross-assembler set up with an Amiga and a C64.
Yeah.
So, but that was very advanced.
Yes, and you were talking about
only the rich
rich
kids.
people and disk drives. So, so the thing I had was just a machine and first a tape drive and then a clone disk drive because actually 1541 was too expensive. I had a clone drive. So, but anyway, so today, like I said, we have this modern environments where you can write with a real working good keyboard. Very important. C64 keyboard is nice compared to the other keyboards like Spectrum. But
Like what?
But still it's not maybe the best considering today's ergonomics. So you have a nice keyboard, you have a text editor, and you can compile and run the thing with a single key press. And then if something crashes, you don't lose the stuff that you are doing. That is what I had. I don't know about the good coders, but I had many cases that when I did some code and it crashes, so then actually your source code went away. If you
My code works first time every time.
Yeah.
Gotta love the confidence, right?
Excellent. I need to learn that someday.
I would conclude on that and say one thing that has really changed from the 80s to today is the involvement of different roles, meaning an artist today. I would argue that the graphicians on the C64 are just as much coders as the coders are. Examples would be like Finnish gold layers. Hal did a lot of the design, the whole conceptual design of making the thing work, because he knows the inner workings of the machine, the limitations of the format. So he can create graphics and data that is programmable. And that is one very big difference, because back in the day, we'd just sit down and write an effect, and if we had a good friend who could draw, magic happened. But today it's very different.
Okay, so something we could take home from this discussion is that things seem to be easier, faster, and also, by my own experiences, not so much with the C64, we can also do things that you couldn't back in the day. Like we can do all sorts of like sound converters and all sorts of like optimized character crunchers that would have taken ages or being next to impossible on a real machine back in the day. So, yeah, seems we are being facilitated by new technology, which brings us to the next question. Actually, what do you think? Is it somehow fake using cross-development tools? Is it more genuine programming on a real machines? Some people still seem to be sticking to them.
I guess it just depends on how much pain you want. I don't think anybody in the right mind would actually limit themselves to develop demos like we used to do back in the day. That would be way too painful.
Yeah, I mean the end result matters. How you get there, I think, is irrelevant. Because of course, when you're doing something, and then of course at the end you verify with the real machine that everything is as expected and so on. And the emulators are so good today that there are hardly any surprises. Maybe related to the disk drive, but for the CPU part, I don't know. I think that it would be very, very interesting to hear from a person that says that doing modern way development is not actually real development.
I think the last thing I did already years ago with the real machine was a driver for PlayStation controllers in the C64. So I just wire to joystick port this PlayStation controller and make the SPI work there.
Oh, that's cool.
With the assembler, so I could make a SID Hero, with a Guitar Hero controller.
Yeah. Oh man! Wow.
That you had to do with the real machine to get it working, but otherwise, no, it's too difficult, too time consuming. Nowadays you have less time for hobbies than you used to have as a kid.
But of course, you always have to watch the demos on real machines. That's so important. Yeah. I mean, unfortunately, so many people watch the demos on YouTube, and it's not just not the same. It doesn't work. So you whatever development platform you like and you want, you can do whatever you want. How, as Scorpion says, how you reach a goal doesn't matter. As long as you reach the goal, it's fine. Just watch them on the real machines, for God's sake.
So, has the C64 become some sort of like reference these days? Like, it needs to run on that, but everything else goes. Like, anything else goes.
Yeah, and that's true. And it's also a very good thing. How many other platforms have stayed the same, that you can compare your skills to other people, or everybody can pretty much watch them? Just check out the Amiga scene. Nobody has normal Amiga. that you can compare. C64 is simple and stays the same from year to year. So what? It's just an interface to your PC when you develop, but when you actually show something, it's still the same. And one of the things we are still doing with the real machine is the music. You can't really... Yeah, people do the music also with the simulated programs, but I think there is a certain feel to it to create the music real time with the real C64. It's like you were talking about keyboards. When I write text, let's say just a novel, just something out of my head, I found out that I write different kind of text with different keyboards. Even taking an old typewriter changes what my output is. So when you do something with the real machine, it changes your thinking a little bit. So it's not irrelevant completely.
If I had to code on the C64 today, I would probably have quit the scene a long time ago.
Yeah, but that thing about keyboards is interesting, not maybe coding related too much, but if you have a real typewriter, then probably you consider more what you are writing, because you just cannot delete and then
Yes.
come back.
You think about it a little bit more before you put it in.
Exactly, yes.
And same with coding with the C64, you have to really think about it first. You don't want to iterate on the real machine.
Well, the topic of tools has popped up already multiple times, and now could you share a bit, like what kind of tools, you can drop some names, like what kind of tools you use for development these days? What compilers, editors, version control maybe? This is something that maybe people in the audience who want to get into it would also learn something from, like what's the good tool these days for these purposes?
Kick-ass.
Maybe.
That's a cross-platform assembler, right? I guess we all use that.
No.
Yeah.
No? Wow. Amazing.
What? Did you say
Kick-ass?
kick-ass? Oh, no.
You don't use? Oh, wow. Okay.
No.
Well, Danish quality. Come on, man. Even though it's Camelot, but still.
But Rap, come on. I use Turbo Assembler in the C64. I'm using Turbo Assembler now.
You are joking.
No.
Wow. Okay. Okay. If I could just quickly conclude. So we are using Kick-Ass, which is a Java-based cross-assembler. We're using the Vice emulator, and we're using real machines to test it on. We're using Sit Factory, which is a PC program to write the music. Then we're using Picture Converter, or PicCon, which is a tool that Walt made, which is absolutely amazing and digs into the whole story of creating the right data. It can do so many things, you would not believe it. If you're curious as a coder, come and talk with Walter or I, and we'll tell you about it in detail. But it's a homebrew picture converter, graphics converter tool. And we use Git to store our code. We use sometimes, depending on the production, we'll use CI/CD pipelines to create the build. So when we push some code, it will automatically build the demo, and we'll get a D64 image back in a channel on Discord, and it happens automatically. So when our coders ship in, it will just update, and graphicians, musicians can see the changes immediately. It's very fast.
Yeah.
So the environment I'm using doesn't require Java. But anyway, pretty much the same. So a regular text editor, some are using whatever. I'm using Notepad++. And then I have this execution add-on that you can actually, with a single key press, you can compile the program and run it on the emulator Vice, and so on. And you can also choose to also exomize and pack the thing and so on. Then of course we use, like Trap said, different kind of programs that help our lives, like these image conversion tools and then editors. I think our graphics, they like Multipaint. That's an excellent program.
I hope Tero is there to hear this.
Yeah, and then PNG to PRG and all kinds of tools and so on where you can convert your stuff, making life faster and easier, and so on. So and building your disks, you can use, of course, these DALI packers and then loaders and then CC 1541 program to create the disk images and so on. So it's so easy today to actually get rid of this kind of regular routine with these programs. You can write scripts to those and so on and so on. So you can focus actually on the development side, not too much on how to get this thing done and run on the machine. And that is good, because it lowers the entry barrier to making things on the machine. So you can focus actually on the coding and the graphics and so on, not too much on how can I make this thing run and so on. And that's a good thing, I think.
I should add, actually, we all our demos, they are built on top of Spindle, which is, what do you call it, a loader framework that LFT made. So we or mostly Walt, developed a whole platform on top of that. And so when we start coding, the whole loading system, everything is already done for us. We have macros that will automatically preload the next part while the current part is running. It will figure out the memory layouts, everything for you. You just code the goddamn demo.
Yeah, that's nice.
That's really nice.
I don't use any of that. Like as before, I always use the same tooling for C64 that I'm using for work. Nowadays, I'm working a lot in real life with Python.
So you're using the C64 for your work today, right?
No. I have used.
Really?
That's a one different story. But I'm using Python for everything. So I have PyCharm where I run Python. I've done my own assembler in Python.
That's cool.
I have all the image tooling, converters, car packers, sprite converters, everything in Python. And because the assembler is myself made, I can add these converters and everything as assembly commands. So I don't have to convert and then add data to my assembler. I can just import PNG image with these converter options. And when I run the Python, it will compile it all and run the simulator. So that's my environment. It's very flexible because it's my self-made and I can add into it a lot. Yeah, I realize it's a very different part. But yeah, Python is simple, very powerful with the image thingies, with the when you're creating your own pre-rolled code or any kind of pre-calc, it's very easy in Python, and you can just combine the C64 assembly and the Python together and run it, and it will create the effect you want. And in this sense, parameters for the effect are very easy to try out because it will, with one click, convert and calculate everything and run it.
Yeah, that was a very good point from Tape. So I didn't mention that, but of course we are using programs made with Python or C language or whatever to do, for example, some 3D calculations or animations and so on. And then we just code it like the way that then it can export data in byte format that you can include directly into your C64 project.
Yeah. I'm just missing the extra steps, so I don't convert the files and then import to the assembly. Just does it with one listing, everything.
By my own experience, about 50% of the time when making an 8-bit demo is spent on various converters, creating converters and modifying them to suit the current needs. So that's a big part of the work. Now, Scorpion there is plugged in, and Could you show us a little of how the magic happens?
Yeah, so can you guys change the screen if this is visible there, this presentation? All right. Yeah, so I thought to have a very quick speak because we don't have too much time, so I'll make it quick, but I made this real-time SID visualizer, meaning playing songs and showing a kind of oscilloscope visualization of the music. So before I start with the presentation, let me show how it looks like in real life. Can we get the audio?
I can hear it.
So we don't get audio, so this looks like some random No, this is Flex, so maybe Flex can do it.
See some modern tooling at work.
All right, very sorry about this. C64 works better. And then I wanted to talk a bit about how it works, and then I cannot make this thing do anything. All right. All right, so this visualization code, so what actually happens when you want to do something like this? What do you need and how do you code it? So the SID chip has 3 channels, 8 octaves and whatever and whatnot. You know pretty much how it goes. But how it works when you want to produce music is that you write to the SID registers in the memory. And the thing for music visualization is that the SID chip registers with a couple of exceptions, are write only. So you cannot read stuff from the SID chip. But what do you need for this kind of visualization to work is that you need to know for each music channel, you need to know the frequency of the voice that is being, or the sound that is being played. You need to know the waveform, whether it's sawtooth or triangle or pulse or noise and so on. Then what you need to do, we need to know is the envelope or the volume of the channel. And then of course master volume and then filter stuff. So how do we do that? Or how do I do that is that actually when the music player, typically Code Tracker or SID Wizard or whatever it's used, you call the music player, but before you do that, you actually change the memory settings of the machine so that the writes are not going to the SID music chip itself, but it goes under that area into the RAM. So actually, you then have the information stored in RAM, and you can use that. Of course, you need to actually then write to the actual SID chip to make the actual music to play and the sound to be heard. But with this technique, you can then, of course, if you write to the SID and it goes to the memory, you can actually buffer the music and you can start write it down to memory and then play it back later. So you can create this kind of piano roll effect where actually you see in advance what the notes are going to be. The challenges to doing this is that, well, the note frequency has 16 bits, and if you're using the pulse waveform, you have 12 bits. Envelope values, like said, cannot be read from the SID chip except for channel 3, which you can read. And then you have the filter, you have low pass, band pass, high pass filter, and combinations. You can enable any of those the way you want. And then you have a cut-off frequency for the filter, that is 11 bits, I think, and resonance, which is then also 16 different values. So. And these more interesting effects like ring modulation and sync modulation, they produce all kinds of interesting waveforms. So this is where we start, and it's a daunting challenge. All right, so how to go about this to do something meaningful that the C64 can actually do is that, well, for note frequency or the frequency of the channel, I have a note matching that actually reads the 16-bit value and then calculates that what note it is. So 440 Hertz is the regular A tone and so on. So I can pretty easily get the value, get the actual note that is being played by the channel. Then pulse width, too many settings to actually do anything meaningful. So I'm using a limited number of pulse widths, like 32 different curves. That's already pretty good. And then for the filter, I did some extensive work on checking that how the filter how the filter impacts the volume of the channel. The emulating waveform coming from the filter, whether it's low pass, high pass, band pass, or some combination, that's impossible to do on the 64, even with pre-processing. But for these volume parts that I'm using in some of my visualizations, not in this oscilloscope, but I have estimates that how the filter impacts the sound volume. Then envelope, like said, available to read from the SID chip from channel 3, but not from channel 1 and 2. But it has this ADSR curve in the envelope. So what I did is that I created an envelope simulator that runs through the envelope as per the commands to the SID chip. And then for the waveforms, I did tabled waveforms, each one of those neatly 255 bytes, meaning 1 page, and triangle, sawtooth, and noise, just random, is easy. And then I did one for sine wave for certain purposes. And then 32 different waveforms for pulse, waveform based on the pulse width. And then I did a calculation that when you run through this 256 bytes, then based on the channel frequency, how fast the stepping goes. That first I saw this part of the waveform, then the next one, is it the same, or is it the one after it, or one later? What kind of pseudo fractional calculation, like in Bresenham line algorithm and so on. So you step with different speeds. And this is maybe not too interesting, but then I just plot the values to the screen. And this is the interesting one on how actually, when looking at the code that is running, how long time does it take for each part of the system to run. So this is one frame, meaning 120 millisecond screen draw in the C64. And oops, sorry. So the envelope simulator is here on gray. As you can see, it doesn't take too much time. Not matching on green, not too much time. But then these are the calculations on the waveform. So which sample should I take from the waveform based on the note frequency? And these are then the multiplications to read from the waveform pattern and then multiply with the volume. And so this is how it then looks in actual running of the code. And this is the arpeggios channel, and this is the bass, and this is the beeping channel. But yeah. So if anyone is interested, I can submit the PowerPoint or the PDF, the presentation to the party files. Thanks.
Tons change, but it seems raster time meters still are with us and will be in the foreseeable future. And now, as the next thing, Trapp will, after a little technical hassle, Trapp will show one effect and how it was made and discuss. Well, I won't spill the beans. I'll let the man explain himself.
No? Okay. Okay, I'll just use this. Right, so I wanted to quickly go over the tunnel effect in Bromance, because that pretty much illustrates what I said earlier about one thing is to have a coder, another thing is to have a graphician who understands the machine and the limitations. So the tunnel in Bromance, if we can quickly show that, so we're all on the same page on what we're talking about here. The C64 is fully capable of making real-time 3D graphics pre-rendered to some extent, or at least make it look like it, and that's what we're looking at here, right? People who have no idea what the machine can do and what it is will maybe think, so okay, so this is actually vector graphics running on a C64. But it's not, it's just an animation. It's all about memory management and creating the right data. Walt, he has, you can turn off the sound, we don't need that. Walt, I'll quote you for that, Walt. Show me your data and I'll write the code. And it's so true. This particular part, you can show the other video. Oh, you're not up there. Oh, okay. Okay, I thought you already seen it. Don't stress, the entire world is looking at you right now. We're just waiting for you. So the idea with the tunnel is, it's an animation, of course. But in order to make it look like you're inside this tunnel and you're turning around 360 degrees, or 180, I can't remember. I think it's 360, yeah. I'm just moving around on a big animation. It's an animation consisting of 8 frames, which rotates the graphics half of the way. Then I switch the colors around, so black becomes white and white becomes black. And I restart the animation, so it looks like it's 16 frames. Ah, there you see. You see it? Yeah. Ah, good. So what you're actually seeing on the screen is the lower part, right? And the upper part is what it looks like in memory. It's well, half of it. So there are some tricks to it. As said, it's inverting the colors to get 16 frames instead of just 8. That's one thing. Another thing is in the middle of these two. It's the same graphics that is just running, but panning across the screen, I have to find the exact right spot to switch between the two animations. And it's really up to the graphician to make this work, because these 8 frames, I believe the size of this was like 888 times 250 pixels. So it's very, very big. And that has to fit in memory. And it has to fit within a single font. It's all in char mode. And Dice, who made the graphics for this, it was quite a struggle. Both Walt and I, we did what we could, but I would, to some very large extent, say it's Dice who made this part work. And I would say it's the same with the layers demo by Finnish Gold. There was Pal who had some really, really cool ideas how you can use graphics, and that's, I think you will see this a lot. Creating the right data is what makes the world go around in a good C64 demo today.
Yeah,
Fake it till you make it.
Yeah, I can add to that actually that is a very good point that Trap made, and I think wasn't mentioned yet today, is that in many cases coding for the C64 or making demos is that actually if you are a graphician that you make graphics, then actually in many cases you also need to be aware of the machine and actually be a little bit of a coder as well. So how do you make the graphics and how do you organize that to the memory, and whether it's a character animation or bitmap animation or whatever and whatnot. So might be that your graphician in your group is actually a little bit of a coder as well.
Okay, sad to say that our 50 minutes are up and we have to wrap up here. Thanks you once more, Scorpion, Tape and Trap, for coming here. Let's give a big hand to the guys. And continue these discussions, you know now who's who, and after the panel, then if there was something you want to discuss, then go and find the guys. And next up is a related topic, Addicted to Fun, indie game making panel with our game developers. Stay tuned. Thank you.